Good morning, ladies and gentlemen. It's wonderful to see you all talking. I think many of you have already enjoyed each other's company, and this is exactly what you should be doing here. I think this is about communication across disciplinary and institutional boundaries. It's wonderful to see you all here. We have a interesting program prepared for you, and we are also looking forward to your contributions here. It is my great pleasure to welcome Dan Mote, our opening speaker here. When we started to organize this event, we had quite a bit of support from Academy members, especially members from the National Academy of Engineering. And I'm an engineer myself, an electrical engineer, and I like to build things. And it was just wonderful to see how much of this kind of research is actually also done by engineers, which are not necessarily just want to control systems, but they also are interested in governing systems. And I think that's ultimately what we should be doing with science, technology, and innovation. We should govern it because it's a very valuable and very important process and effort. And the talk here and the conference, which brings us all together, is really envisioned as a means to brainstorm and also understand collectively better how decisions can be made in a much more data-driven way, with the support of not only small and big data, quantitative and qualitative data, but also with the support of visual analytics tools and with the support of computational predictive models. And so as part of the conference, it's my pleasure to welcome Dan Mote, the president of the National Academy of Engineering, also former president of the University of Maryland. Some might still know you from that role. And without further ado, please stand.
Let's see. Well, thank you very much for that introduction, and especially for the invitation to come here. Actually, my role is actually just to welcome you, but of course I can't control myself entirely in this. So oops, I guess I'm not going to use these anyway. So I don't know if it's better to have it dark or light. I'm very pleased to have this opportunity, and I'm really welcoming you on behalf of the National Academy of Sciences, Engineering, and Medicine, the Academy complex in this building. And this, of course, I think is a very important workshop, as a matter of fact, and it really has a chance to set the direction for this whole domain, which I believe probably needs some attention as well. And I really want to congratulate Katie Borner and Nastasia Woloshevik? No, Stasia? Close. Anyway, sorry about that pronunciation. And their team of advisors for organizing this cross-disciplinary workshop. I'm really delighted to see science, technology, and innovation really span this important conversation, since technology is an outcome, basically, normally involving people. And I also expect humanities and social sciences are woven into this conversation, though not explicitly in the title. Collaborative dialogues like this really are important for this topic and on modeling and analytics, and more of that is needed. Now, a model really is simulating the present, past, and future of something. It's prehistoric in concept. It's older than science, engineering, and humanity itself. Man has survived from the beginning of humanity through the creation of models and relying on them. The earliest models were transmitted orally from generation to generation. The advance of humanity can be traced to the advances in modeling, to more reliable simulations of the past, present, and future. Models simulating the motion of particles, the wind power on a sail, the strength of materials, the healing of tissues, the transmission of disease, the making of fire, the behavior of people, and so on, have long determined policy and practice. Today, as the understandings from scientific discovery and engineering creations, inventions, social sciences, and cultures have been accelerating throughout the world, the advancement of models of them and the coupled behaviors of all the subsystem models like how does culture determine the acceptance of innovation by people, think GMOs, must necessarily follow. We are challenged by the scales of the expanding understandings and the models simulating them. The modeling of coupled subsystem behaviors is an ever-challenging topic that may be uncovered through data analytics that has only recently become possible because of course, you know, the access to large data volumes and the advanced computational tools for dealing with them. However, the need for models that simulate the past, present, future remain as critical as ever because policy, laws, education, and truth will be based on them, like it or not. Confirming a single model's relevance is relatively straightforward. Test it, use it, compare it to reality. But as models become more complex, involving many subsystems, it becomes increasingly difficult to conclude the complex model actually simulates the system behavior we intend it to simulate, especially when people are involved. Now, recently I came across a story, which I can't validate as being true, but enough of it is true that I believe it, in a sense, that sense. And that had to do with a group, a young group, that went to a remote village to see how they could help the quality of life in this village. And they noticed it had no running water and no electricity. And the women in this village had to walk many miles, a mile and a half a mile to a mile from the village to get water and haul it back to the village. And they had to do this 2 and sometimes 3 times a day. And this was very time consuming and hard work and so forth. And they realized they actually could bring water to this village from a spring uphill of the village. They discussed it with the villagers. Everybody seemed to think it was a great idea. They went home, designed the water transportation system, aqueduct system, raised the money, bought the parts, came back to the village, installed it, it operated, and they and the villagers had a tremendous party afterwards celebrating the water supply to this village. What a great time it was. They were very personally satisfied, of course, as they left this village. And then 1 year later, they returned to the village to see if everything is working okay and any corrections need to be made and so forth with this system. And they found, to their surprise, that nobody was using the water. And the reason was the women actually liked going to the river because it was their only chance to get away from the men. They went to the river to discuss what was going on in the village and so forth in a very candid way they couldn't do otherwise, so they just continued to do so. So this is a failure in system approach to a multi-model problem. They forgot the big question, will they use it? So as systems get more complex, missing important pieces become increasingly likely, like the village example. More data on water, more data on weather, more data on costs of operation and maintenance would not have helped the solution of this problem. Better analytical tools would not have done much for it either. So more data is frequently the wrong answer to the right question. Are we modeling the system correctly? Are we modeling the right system? So there's a caution here. We can get quite wound up on computational schemes, access to enormous data volumes, and intricate data handling procedures needed to bring pieces together. We may even shape the program to the available data implicitly, if not explicitly, and consequently not create the intended system simulation model, no matter how we want to describe it. Taking our eyes off the model to aid the analysis is a risky step without realigning the purpose of the study entirely to create harmony between the modeling and the analytics and the data. So in our village example, for example, a modified model bringing the water near but outside the village might have solved a different but a useful problem. So we're living in an era of big data. Data sets come in different volumes, varieties, velocities, veracities, and many other characteristics that are still developing, and you're in fact developing them. And big data implies to many people quality, and especially capacities for understanding systems which are often not true, as one listens to political pundits and observes election results. However, in the world of public policy, we have a persisting ailment. The answer to every question is a need for more data to inform decisions. even if they are unreliable for the question being asked or the model misses the target, like the village problem. Even more importantly, what often lacking in policy is the systems approach, assembling multiple models, including their interdependencies. Without that, our approaches will always be limited, if not fatal, like the village problem. Data, computing, and visualization are tools used to basically inform decisions. Often they fall short in influencing final decisions because our models don't adequately include human behavior and human factors, as in the case of the village. These tools cannot compensate for an inadequate model, no matter how fancy they may be. Think models, please. Now, there are numerous policy challenges that we face, and let me briefly just touch on one example. Global health policy, a most complicated area. Infectious diseases, as we know, disrupt all barriers. Modeling and analytics certainly have an important role, but other factors to consider include information technology, sensor infrastructure, computational power, and the predictive value of data, and I think you can think of many others as well. The recent outbreaks of Ebola and Zika suggest we can do better in terms of boosting our surveillance and preparedness systems, enabling more timely responses to disease outbreaks. And how can modeling help with that? Well, modeling could advise us on the advanced preparation needed with the right data sources, tools, and strategic approaches to help ground-level logistics and defense against infectious pathogens, especially since we are not surprised by them anymore. We should be cautious about the predictive value of all models, particularly the yet-to-be qualified models, data and understandings from them. Consider the global flu trends, which was designed to, the Google flu trends, which was designed to predict outbreaks of influenza by counting the related search engine queries. Experts have noted how this model dramatically over-predicted the peak flu levels. But really, how could it ever have worked? It may have predicted interest in a topic by those with internet access and concerns about the disease, but predicted outbreaks? I don't see the connection. Reliable models emerge from testing, iterative improvements, and a community of users who validate their quality and integrity. The model is the formation of its value. The right data for a particular model are also necessary to qualify the model. Ultimately, the useful models simulate, as we said, the past, present, and future under stipulated conditions. Models are not decision makers. They underpin and inform decision by decision makers. These collaborative activities are much needed to inform and improve the culture we live in. A few years ago, the Defense Intelligence Agency, DIA, supported an NRC consensus study that I chaired to determine the science and technology strategies of 6 countries, predict whether the country would succeed in their goals and when, and what would be the implications for the United States if they did. The countries were Japan, Singapore, Brazil, Russia, India, and China. Kind of a quite wide range of countries. After looking at each country and looking across all these countries, a committee of 18 people, this is from CIA people to academics to industry people to government people, and so quite a wide range on this committee of expertise. They looked across all 6 countries to see if there were any overarching understanding that could result from this collective of these 6 countries. The surprising result, and I say surprising to all 18 people on the committee, including me, was that the committee uniformly agreed that the most important conclusion of the study was the primary determining factor of a country's reaching its S&T goal was its culture. That is, culture defined by the attitudes, values, goals, and practices of an organization. It was not the usual indicators we use. It was not research investment, it was not engineers in the workforce, and all those other things we talk about all the time. Those are consequences of the culture. Those are outcomes. They are not the foundation. In fact, the advice to the DIA was for each country of its interest, forget all those other factors. Track the cultural barriers to advancement of S&T and the cultural accelerators to the advancement of S&T and in that country, and it will learn everything it needs to know about the country's future strategic profile. The barriers and accelerators are long-term predictors of their S&T capabilities. So because a goal of this workshop is to set an agenda, I hope that you'll think really assertively and broadly about what is really actively needed to be delivered here. Think of active partnerships in various areas of research, practice, and decision. Engage with the public to better communicate the value and especially the limitations of modeling. Be critical of crappy models that are everywhere. Don't just accept them or be silent on them. Be forthright on these limitations, for it's the only way we can shine a light on the difference between good and poor models and the necessity to understand the difference. This is a group that can stand up for quality models and against models without qualification. I wish you really all the very best in this very productive and stimulating and important workshop, really that can lead to a new avenues of inquiry and can set a standard for subsequent conferences on modeling to emulate. Thank you very much for the opportunity to make a few remarks.